Hey everybody, this is Larry. This is day 12 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. What happened here? Did I press something? That's weird. Anyway, 2477 minimum fuel cost to report to the capital. Quick things first. Hope everyone's having a good weekend. And just let me know what you're doing this weekend. I am trying to figure that out myself, other than the Super Bowl or Super Bowl, depending on where you are. But yeah, and hopefully, and also one additional thing is that hopefully, let me know about the sound level. I hope I fixed it. I think I just installed a new thingy and then didn't realize it wasn't using the mic. So silly mistake. But yeah, today's poem is 2477 minimum fuel cost to return to the capital. Just by the high number, I feel like we probably had this on during the contest at some point, or like some point relatively recent, but a little bit of a spoiler, but still, I don't think that I remember. Maybe not. Maybe I lie. Okay, so there's a tree, which means that there are n nodes and n minus one edges. Okay, and then the capital city is city 0, and then you have these roads that are unrated, it seems. Okay, and they basically you're trying to get from each node back to the capital. And capital is, do they tell you the capital, or is it just 0 or something like this? Okay, the capital is 0. Okay. So basically, I think the idea here is that you try to carpool as much as you can. I vaguely remember this one, so it's a little bit of a cheating thing. But if you really wanted to see, because as I mentioned, I believe I solved this during the contest not that long ago, maybe a few months ago, maybe something like that, give or take. I don't remember, but I only remember this one because I think I had I got a couple of questions about it afterwards after the contest, not during the contest, obviously. Well, maybe during the contest too, but but yeah, afterwards. And I think this is an interesting one. At least enough for me to have some recollection. So I don't think that I can solve this in a pure unseen way. But I, like I said, I have solved this recently during a contest, so that's as unprepared as you can be, really. Or maybe not. Maybe unprepared is the wrong word. I wouldn't say unprepared, but just like there's no way I could be. I guess people do cheat all the time in some weird ways, but you know what I mean. In any case, if you trust this channel and all this stuff, but yeah, but basically, and it's, why is this still loading? This is so weird. But I think the core idea is just thinking about I think this problem requires a bit of an understanding of a depth first search tree. I mean, of course, you're already given a tree, but then now but given and depth first search is a thing, but this idea of a depth first search tree, which is how sometimes people just think about recursion as depth first search and all this stuff, right? But yeah, let me see. Okay, let's use this one real quick. Oh, I didn't share the screen. Okay, there you go. So let's say you have something like this, right? And then the idea here is that I think you're given car seat as an input. So then basically you're going, I mean, in a way, you can calculate this in a different way. I mean, the implementation is a little bit different or whatever, depending on how you want to mentally visualize it. But the way that I would visualize it, and maybe this one isn't even that perfect because there's just 3 leaves or 3 branches, because they're not enough merging. But you can think about it from just like going from, say, here, how many this person has to go to here, right? I mean, and this is a tree, right? So that means that one thing that I don't know if it's an observation, but it's just something that is a property of a tree, is that every node has only one symbol path to another node, right? That's just like a definition almost. symbol, meaning that you don't go back and forth or something like this. But yeah, so that means that this person at 6 is now at 4, right? So now there's one person here, and now there's two person here, and then now they could all fit in the car and they go together. So that's basically my visualization, one at a time, right? There's one person here, and then two person here, and then three people here, and then they all go back to the capital, right? And of course this gets more complicated if you like, meaning that say you have something like more nodes, right? Then here and maybe even more nodes, there's one, and then there's two here, there's one here, and then now this is three people, and you can almost, maybe another way of thinking about it is that you can only move one step at a time for each person, right? And you try to kind of carpool them as much as you can together, instead of thinking it where instead of thinking about each person at a time, you're thinking about each stop at a time, right? That's basically really the idea about this problem. And once you kind of think about it in that way, the depth first search problem, or the depth first search implementation, is relatively straightforward. But of course, like I always say, these things, when you look at the code, sometimes it's very easy and very tempting to say that something is easy because you look at the answer, you're like, oh yeah, of course, it's just like 5 lines of code. How hard can it be? But then there are a lot of deeper understanding that is required, and I mean, maybe not a lot. Maybe I overstate that a little bit, but the point is still that there is some deeper understanding that makes the thing works, right? And I kind of talked about a few visualization already. They don't all have to. It's not mutually exclusive or whatever, but it's also just one way to kind of think about, or different ways to think about a problem, such that you can write the implementation in a specific way, right? So yeah, so then now we could do something like calculate node, right? And then maybe we just return calculate 0 for whatever. Yeah, and then yeah, and then edges is equal to collections.default date list, and then maybe for UV in edges, in roads, edges of u.append re, and this is just right now constructing the edge list, or sorry, the adjacency list. This is the edge list, I suppose. The roads is the edge list. My naming is kind of terrible today. And then maybe parent is equal to, yeah, right. And then basically now, calculate. What is calculate, right? Basically, this gives us, the minimum few costs to get all children to node, right? That's basically what this gives us, and yeah, I think that should be okay. Maybe not. I think the way that I wrote it is a little bit presumptuous. Maybe I need to change some stuff around, right? And also maybe we can return two things, right? Give us the minimum few costs to or node to node, and also gives us the number of people arriving at this node, right? Yeah. So okay, so then now we can do something like for v in edges of node if v is not parent, and this just means that you don't go back to the parent. Yeah, and then we have calculate v of node, and what does this mean, right? So we have maybe we could say people and few is equal to this calculation, and then maybe we have total people is equal to say 1, total few is equal to 0, total people is equal to 1 is because of this particular node. We might have to adjust that for say node is equal to 0, but for now it should be okay. And then yeah, total people we add people, and then total few we add few, maybe, right? Yeah, give or take. Isn't quite right because we haven't added the few, but that structurally it should be correct. Okay, so now the thing that I have to think about is how many or where do we actually do the fuel calculation, right? And I believe here, so people, so fuel is, so this gives us the minimum fuel cost to our children to node V. So then now we have to, all these people, the people amount of people, have to go from V to node. So that means that we can add it here, right? It's plus people over seats. Kind of, so we want the ceiling of this, right? Is what we want, and of course, people is going to be a whole number, and so it's seats. So we can actually just do a roundup in a slightly smarter way, which is this thing, something like this, right? I'm not going to prove this here, but you can just kind of work it out at home to see why the two functions that I had were equivalent. Okay, so then now, and then we can just return F. I think that's mostly good, maybe, hopefully. Yeah, looks okay. So let's give it a quick submit. Hopefully I didn't miss an edge case, mostly due to laziness. Maybe I could have thought about it a little bit more. Yeah, apparently it's only been, wow, November's, time flies. It was like 4 months ago, say. But yeah. So what is complexity here? The reason why I didn't really look at constraints, and I maybe still should have, to be honest, is that this is linear time. It's just one depth first search, right? So linear time, linear space due to the edge list. Every node gets visited once, and every edge gets visited once, right? That's pretty much it. So yeah, linear time, linear space, and of course the number of nodes. The number of nodes is the number of edges plus 1. Yeah, yeah. So the big O is going to be the same. So it's still linear time, linear space. And yeah, that's pretty much all I have for this one. So let me know what you think. Let me know if this explanation hopefully is better than the one in the contest from 3-4 months ago. And that's all I have for tonight. I'm going to do an extra premium question because there's a contest later. So just slightly more practice. And if you are doing the contest tonight, good luck. And for the rest of you, or even if you're doing the contest, for everyone else, or everyone in general, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.